What is the formula for the centripetal force? And the answer is mv squared over r. So the acceleration is the v squared over r. That's the centripetal acceleration, the force mv squared over r. Now remember, you can make a substitution of the velocity, orbital velocity or speed, 2 pi r over t. Put it in for v and get m 4 pi squared r over t squared. Now, here is a situation that I think could possibly come up. Imagine something going around in a circle. Here's a toy airplane. Here's how the vectors would go. If that's angle phi, the weight acts directly down. You have a tension acting as shown, and a centripetal force acting inward, Fc. Now, the first thing you will do is, you can label that as angle theta, as I've shown. You must break t into components. Now, you know how to do that, and you can break them in however way you choose to, using either phi or theta. But mg will equal that component of the tension. And you can work out the equations accordingly. And this horizontal one where the arrow is pointing, that is what equals the centripetal force. Now you need to understand what those components equal. Next, what is the formula for momentum? Very simple. P is mv, momentum is a vector, and they add head to tail. Impulse, I noticed on one formula sheet they called it J. I don't know why. But J is F times T. The impulse is force times time, which equals the change in momentum. The change in momentum, final minus initial. Next, what is the basic formula for gravitational potential energy near the surface of the Earth? Notice they use U sub G, and that's potential mgh. For kinetic energy, what's the formula? They use the symbol K, and that's equal to 1/2 mv squared. Next, the formula for torque. There's a fulcrum. There's a force acting at an angle theta at a distance d from the fulcrum. Always, the torque is Fd sine theta. And every counterclockwise torque equals every clockwise torque, Fd sine theta. Next, let's look at the formula for the normal force in each case. In the top one, all that's happening is the weight there pulling down, pushing down, would be mg, and that weight would equal the normal force because the force pulling it is parallel to the ground. If I'm pulling at an angle, what happens is the weight is lessened by that vertical component. Therefore, there's the weight, and the normal force is lessened by that vertical component right here, which is F sine theta. Therefore, the normal force will equal W minus F sine theta. Very simple. Just make sure you understand how that works. It's something that could just come up, I know. Now, if I'm pushing, what happens is I'm increasing the normal force. Therefore, what happens is the weight plus that vertical component. So the normal force would equal the weight plus F sine theta. Okay? It's something I just thought we should review. And also this will help you for the government exam. Next, what is the simple general formula for friction? And the answer is the force of friction equals mu n, mu times the normal force. Mu is the coefficient of friction, and it has nothing to do with the surface area. So mu is the coefficient of friction. It would have to be given to you. N is the normal force. And obviously you would not memorize any constants. And this is just something you should be very, very familiar with. Now, we've already reviewed the normal forces, so that should be pretty straightforward. Now, the next thing I'd like to just review are the two kinds of friction. And remember, it has nothing to do with the surface area. There's static friction, and you would write it as shown there. The coefficient is different, and that's the friction to get it started. It takes more force to get it going than to keep it going. Once you've got it going, you have kinetic friction, and notice you have a different coefficient, and it's a less force to keep it going.